So as we said in the previous lesson, lesson 3 would be about investigating between a numerical and a categorical variable. So in this lesson, we are going to investigate between a numerical and a categorical variable. The outcome of such an investigation will be a brief written report. Okay, so there's a bit of writing in this lesson that compares the distribution of the numerical variable across the categorical variables that it can take. So we'll use parallel dot plots, back-to-back stem plots, parallel box plots. We will compare the distributions of the numerical variable for each categorical variable according to its shape, center, and spread. So looking here at this box plot, there's 2 of them, so therefore it's a parallel box plot, as long as there's 2 or more. And you can this is what we're going to aim to achieve, to understand the difference between these 2 box plots. Straight away I can see that the median is higher in the first one, and also that the range is bigger in the second one, okay, because it's more spread out. That's the kind of thing that we're going to be looking at. We're also going to be looking at, is it symmetric or skewed? And we can do the same thing for the dot plots, okay? With these though, they need to be in line. Okay, so as you can see, the number 1s line up, the number 2s line up, and so on. And with the parallel box plots, same thing. Okay, they're all under one timeline. All the numbers here are for both box plots. So the parallel dot plots below display the distribution of a number of sit-ups performed by 15 people before and after they had completed a gym program. Okay, so here we've got number of sit-ups before, what they could do, and then after the gym program. You'd hope that these dots would start to be more on the right, and it looks like it. So do the parallel dot plots support the contention that the number of sit-ups performed is associated with completing the gym program? First, let's identify which one is the numerical variable and which one is the categorical. So numerical is the actual sit-ups, number of sit-ups, and categorical is the gym program before and after. Is the gym program taking values of before and after? So what we're going to do is we're going to write a brief explanation that compares the distributions, and it's sort of broken up. I'm trying to make your life a bit easier, not getting you to copy down as much, but we still need to sort of follow this sort of guideline here. So the first thing is find the median number of sit-ups performed before and after the gym program. So the first sentence is the median number of sit-ups performed after attending the gym program. Well, once you work it out, I'll get you guys to work it out, but you should get a median of 32 is higher than the median number of sit-ups performed before attending program, before gym program. And the median from before the gym program was 26. Okay, so that was the first thing we did. Talked about the median and which one was higher. Then we want to determine the IQR of the sit-ups performed before and after the gym program. So looking here, up here, we can work them out. It is going to take a bit of time, but you all know how to work out the IQR and the median from these dot plots or from this data. So the IQR, or the variability, is what we're talking about when we say IQR, variability, in the number of sit-ups has also increased. Once you work it out, you'll notice that it was increased from IQR equals 6 to IQR now equaling, after the gym program, equaling 10. So even if you look at it here, you can sort of see the IQR, or at least the range, you can say. This is where the data is here, and then it sort of just gets bigger. Okay, that would be more for the range, but if you work out the IQR, you'll also notice that the range has gotten bigger. Thus, the whole point of this, we can conclude that the number of sit-ups performed is associated with completing the gym program. Okay, so in the end, with this gym program, these people can now do more sit-ups. We're also going to compare back-to-back stem plots. So how to read these is the same way you would read a normal stem plot. So what you're used to is just something like this maybe. But we're just going to compare two different years. So 2010 is here for this data, and 1970 is here for this data, sharing the same stem. Okay, but the only difference is with the left one is that they go in this direction, whereas the 2010 one goes in this direction. So firstly, identify the numerical and categorical variable. Numerical equals, what is it? We're talking about two different years, but also life expectancy. So the numerical is the life expectancy, and the categorical is the year. And the only reason why this is categorical is because it can only take two values. The year, taking only the values 2010 and 1970. Okay, so now if we're going to write a brief explanation that compares the distributions. Firstly, we can talk about the median. Okay, so once you work it all out, the median has increased from 1970 to 2010, from 67 to 76. Over the same period, life expectancy has also become less variable. So whenever we talk about IQR, talk about variable. So it's gone from 12.5 down to 8. And therefore, we can conclude that there is an association between year and life expectancy. Okay, so we're ticking off almost like 4 sentences. Determine the median, determine the IQR. Are they sufficient enough to conclude that this has changed over time? So as long as the median has changed, and as long as the IQR has changed, then yep, we can say that the life expectancy has changed over this 40-year period from 1970 to 2010. Alright, now we're looking at comparing box plots. It's the same thing over and over again, just different sort of ways of looking at it. So what is the numerical variable here? The numerical variable is the resting pulse rate, or just the pulse rate, sorry. And the categorical equals gender, taking values as male or female. And then we're going to write another brief explanation. Okay, so what we have here, again, talk about the medians, compare the medians. It is lower for, the resting pulse rate for males is lower, 65 compared to 72, and it also is less variable than that for females. So IQR for the males is 10, for females is 15. Then we want to talk about because they're box plots, we can talk about the shape. So is it symmetric or distributed? So remember what we said in a couple of lessons ago? If it is symmetric, the median seems to be in the middle of the box, and the two whiskers seem to be even in sort of its length. Otherwise, the median would push to the left and one of the whiskers would be bigger. So in this case, we can see that the distributions of resting pulse rates for both males and females were approximately symmetric. Okay, so that's what it looks like for both. You can see that this line here is sort of in the middle of the box, and that the whisker is, for both of these box plots, is roughly the same. So therefore they're both approximately symmetric. Let's locate any outliers. Okay, in a box plot you can very clearly see where the outliers are. There exist two outliers. One male was found to have an outlier at 40, while another had an extremely high pulse rate of 120. And therefore, considering we have, the medians have been changed, and same with the IQR, we can say that there is an association between the resting pulse rate and gender. Last example. Alright, so this is about salary for a bunch of age groups. So 20s, 30s, 40s, and 50 to 65 year olds. So what is the numerical variable? Well, that should be, if my thing works, that should be the salary. Okay, so the numerical variable is salary, and the categorical variable is age group, which takes the values 20 to 29, 30 to 39, 40 to 39, and 50 to 65. What we can do now is give a brief explanation that compares the distributions. Alright, so first things first, compare the medians. What we want to do now is we want to talk about the median across the age groups. Okay, so the median for here at 20 to 29 is somewhere between 60 and 70, which is probably like 64. Then it goes to here, which is about 68. Then it goes to 71. Then it goes to 72. So we can see that the median is consistently getting bigger. And you can even say just the beginning and the end. So from 64,000 for the 20 to 29 year olds, and then 72,000 for the 50 to 65 year olds. The salaries also become more variable. So then talking about the IQR. Okay, so the IQR increases from around 12,000 for 20 to 29 year olds, and then to about 20,000 for the oldest age group. Then we talk about the shapes. So the shape of the distribution changes with the age group from symmetric to progressively more positively skewed. So as you can see here, it looks like a symmetric shape for the box plot. And then here at the end, we can see that the right whisker gets bigger, and obviously the more outliers here. And also the left whisker gets smaller, and the median gets pushed more towards the left of the box. Okay, so that means it's becoming more and more positively skewed. There are no outliers in the first two age groups, but they begin to appear in the second two age groups. So because of all these changes, there is an association between the salary and the age group. And that should be enough for lesson 3.